So this video is looking at chapter 13 of year 1 pure integration. Now integration is the opposite of differentiation, and just like with the differentiation there are a variety of notational symbols you need to learn. So in question 1 we use dy dx for the gradient, and to integrate means to find the original function. In question 2 you use f dash of x for the gradient, and we want to find the original function. And then in question 5 and 6, we have the long S to mean the integral of the thing that's between it and the dx. And again, all three of these mean integrate. Find the thing which, when differentiated, gives us what we have. In question 6, we have limits, which basically means we integrate and then we put in the top limit, subtracting, putting in the bottom limit. And then in question 8 and 9, we see that this actually is what we do in order to find areas. I call them pseudo areas because they can be negative. Okay, so let's have a look at each of the individual questions. So for question 1, we have dy dx equals x to the 6, and we're going to find y. So this is the reverse of differentiation. It is integration. So when we differentiate, we bring down the power and reduce the power by 1. The reverse of that is to increase the power by 1. So x to the 6 becomes x to the 7. And then we take the reciprocal of that power and multiply by it. Or another way of saying that is that we divide by the new power. So we add 1 to the power and divide by the new power. So x to the 6 adding 1 to the power becomes x to the 7. And then dividing by that new power, we get 1/7. I prefer to multiply by 1/7 than divide by 7, but it's the same thing. We need a plus c because actually, if I differentiate 1/7 x to the 7 plus anything, like 2 or 7 or minus 6.3, they all differentiate to x to the 6. So when we integrate, we need to say it's a family of curves, all of which are 1/7 x to the 7 plus any constant. And you might want to check this. If I differentiate x to the 7, I get 7x to the 6. 7 cancels with the 1/7 to give me x to the 6, and the c goes to 0. So you should be able to verify your integration by differentiating the result and seeing that it differentiates to the original. Okay, question 2. What's hard about question 2 is that before integrating, just like before differentiating, we need to write down our expression as something times x to a power. So 2 times 1 over root x, or 2 over root x, is the same as 2 times x to the minus a half. And then we apply the rule for integration, which is we add 1 to the power. So become adding 1 to minus a half gives us plus a half. And we divide by the new power. Dividing by a half is the same as multiplying by 2, turning a half upside down. And so we get 2 times, because the 2 was already there, the reciprocal of half, x to the half. So this becomes 4x to the half. And writing out the x to the half is root x. This means it's 4 root x, not forgetting the constant of integration. Be careful, in an exam, you may well lose a mark for not having the constant of integration. So in a 3-4 mark question, 1 mark just for having the plus c when you're doing integration. Question 3, we have an expression here. Before we can integrate it, we need to divide out. We know we need to integrate it because we're given the gradient function and we want to find the original function. So before integrating, x to the 4 divided by x squared is x squared, 3x squared divided by x squared is 3, and minus 4 divided by x squared is minus 4x, minus 4 divided by x squared, which is the same as minus 4x to the minus 2. Now we have it in this form, we can apply our rules. X to the 2 increases to a 3, and we multiply by 1/3. 3, the best way I think of integrating this is to think of what has a gradient of 3, and that is 3x. And then applying the rule to 4x to the minus 2, we add 1 to the power. Adding 1 to minus 2 gives us minus 1. And then multiplying by 1 over minus 1 changes the sign of a minus 4 to a 4. And of course the plus c. And then if we rewrite that, writing x to the minus 1 as 1 over x, we get 1/3 x cubed plus 3x plus 4 over x plus c. And again, it would be good practice to differentiate this to make sure you get the dy dx that we have here. Okay, question 4. gradient function is 3x squared minus x plus 2. We want to find the original function, and we're told that when the original function we input 1, we get an output of 5. This will enable us to work out the constant of integration. So first of all, we integrate. The integral of x cubed is the integral of x squared is 1/3 x cubed, multiplied by 3 is just x cubed. The integral of x to the 1 is 1/2 x to the 2. So the integral of minus x is minus 1/2 x to the 2. The integral of 2 is 2x, and we have the plus c. And now we're ready to use this information to work out the c. So feeding in 1 into our function, the output is 5. So it means feeding in 1, we get 1 cubed minus 1/2 times 1 squared plus 2 times 1 plus c equals the output of 5. If you then solve this equation, you get the c is 5/2. And now we know that f of x is x cubed minus 1/2 x squared plus 2x, and the c can be replaced by 5/2. So this is the function which, when differentiated, gives us 3x squared minus x plus 2, but also has the boundary or constraint condition that f of 1 equals 5. And we can check that by putting 1 in here and seeing that we get 5 coming out. Okay, question 5. Same really as questions 1 to 3, but we have different notation. So this basically means find the integral of 2x cubed plus 1. And the dx is kind of a termination of what it is that we want to integrate. We'll see later it means something else as well, but for the moment, that's all you need to understand from it. So if we integrate x cubed, we get a quarter x to the 4. So the integral of 2x cubed will be 2 times a quarter x to the 4. The integral of 1 is x, and then we need the plus c. And so that's it. This is basically saying that the integral of 2x cubed plus 1 is a quarter x to the 4 plus x plus c, because when we differentiate a quarter x to the 4 plus x plus c, we get the 2x cubed plus 1. Now coming on to this addition in the notation, if you want to do what's called a definite integration has limits. What you need to do is you need to do the same as indefinite integration, where you integrate the terms. You don't need a plus c. You put your answer in square brackets, and then you put the limits in as well. And then the next stage, and you must do this notationally, be careful to follow this exactly, is that you substitute in the top limit into the expression inside the square brackets minus the bottom limit substituted into the expression. So let's have a look at it. 6x squared integrated is 2x cubed, minus 4x integrated is minus 2x squared, and 1 integrated is x. We don't need a plus c. More about that later. So we simply say the integral of 6x squared minus 4x plus 1 is 2x cubed minus 2x squared plus x, and we leave the limits in by putting the limits that were in the long s into the right-hand square brackets. Now we substitute into the square brackets x being 2, so we get 2 times 2 cubed, which is 16, minus 2 times 2 squared, which is 8, plus 2, which is 2. We work that out. Then we subtract, substituting in 1, which gives us 2 times 1 cubed minus 2 times 1 squared plus 1. And if we work all that out, being careful with the brackets, we get 9. Okay. What does that mean? Well, that means that the area or pseudo area underneath 6x squared minus 4x plus 1 from the x value of 1 to the x value of 2 is exactly 9 square units. Okay. More about that later, but you need to be able to simply perform this calculation, realizing that this notation means you integrate, substitute the top limit, substitute the bottom limit, subtract. Please use square brackets immediately after integration, and then please show the substitution of the top limit, the substitution of the bottom limit, and the subtraction between both. You will get a method mark for that in an exam, and if you just have the final answer without all that method, you risk losing that. Okay, so the integration of 1 plus root x between limits 1 and 4. How do we do it? Well, first of all, we need to write it as powers of x. So it's the integral of 1 plus x to the half. So the integral of 1 is x. The integral of x to the half becomes x to the 3/2. Adding 1 to a half gives you 3/2. And then dividing by 3/2 is the same as multiplying by the reciprocal, which is 2/3. So the integral of 1 plus x to the half is x plus 2/3 x to the 3/2. No constant. Same limits. Now we substitute in the 4, and we get 4 plus 2/3 of 4 to the 3/2. that's 16 thirds because 4 to 3 over 2 is 4 square rooted cubed, which is 8 multiplied by 2 thirds is 16 thirds. Then we substitute it in the 1, which gives us 1 plus 2 thirds, and then we substitute then we subtract the first answer, so that we take the first answer minus the second answer, and we get 23 over 3. Okay, going on to questions 8 and 9, we're now asked to work out an area. And so this is where we need to understand the integration notation. So if I want the area trapped between y equals 4x squared and the x-axis, so that looking at this is y equals 4 minus x squared. If we look at when, so this area here, so we want to look at where the curve crosses the x-axis, we say, well, when is the y coordinate 0? The y coordinate is 0 when 4 minus x squared equals 0, which means that x equals plus or minus 2. So this x coordinate here is minus 2. This x coordinate here is 2. So what we want is the area underneath the curve. So from the curve to the x-axis, starting at x is minus 2 and going up to x equals 2. And that's exactly what definite integration gives us. So now if we perform that, the integral of 4 minus x squared is 4x minus a third x cubed from minus 2 to 2. We substitute in the top limit, we substitute in the bottom limit, subtract, we get 32 over 3 or 10 and 2/3. So the area trapped between this quadratic and the x-axis from minus 2 to 2 is exactly 10 and 2/3 square units. Okay, so find the area trapped between x plus 1, x minus 2 and the x-axis. Here we see that actually there's an area above the x-axis and an area below the x-axis. And there's going to be a problem if we just integrate across both of them, because this area here, the one above the x-axis, will, with definite integration, give us a positive answer, but this area here will give us a negative answer. More about that, why that is the case later, but it does. So if you want to actually work out the area and not the net area, counting this as positive and that as negative, we need to work them out separately and only count them as positives. So what we're going to do is going to integrate from this x-coordinate to this x-coordinate, and then separately from this x-coordinate to this x-coordinate. So what's the x-coordinates? Well, they are minus 1, 0, and 2. So we're going to integrate from minus 1 to 0 and get this area, which is 5/12. Integrate from 0 to 2, which gives us a negative answer. Notice it's negative because the curve is below the x-axis. So this area here is 5/12. This area here is 8/3. And if we want the total area, we're going to take 5/12 and not add minus 8/3, but add plus 8/3. And that gives us an area of 3 and 1/12. So if you're given a definite integral, you just do what you're told. If you want to work out an area, you need to ask yourself, is the area completely above the x-axis or completely below the x-axis, or partly above and partly below, and then do accordingly. Okay, that's very fast, but hopefully with the presentation and more practice, you'll get used to it. Please do ask questions on this. There's quite a lot involved, and there are likely to be quite a few questions associated with these techniques. Okay, that's it for this prep practice, and the prep test next Tuesday will be very similar.